صباح الخير جميعا ومرحبا في مكتبة اسكندرية. Welcome, ladies and gentlemen, to the Library of Alexandria. My name is Ismail Sirajuddin, and I'm the director of the Library of Alexandria. I'm also a veteran of the World Bank, a veteran of IFPRI, and a colleague of long standing with Clemens and with other people there and here. And also, I think you have met Dr. Noha Adli, who was a founding member of the Library of Alexandria with me, who built up with Dr. Magdi Nagy here the entire ICT program of the library, including the fact that we have our own supercomputer, which therefore means that no matter how complex your models, we can run them for you. There's nothing that you can think of that we cannot handle. After all, we have over 100 teraflops per second in a computer. That's very high indeed. But today, I'm particularly happy to welcome you all here, because this marks something that I'd been hoping would happen for quite a while, which was a new level of collaboration between the library and its budding group that is dealing with advanced research, and an institution for whom I have a lot of love and affection over the years, which is IFPRI. For 7 years, I had the rare privilege of being the chairman of the CGIR, which is kind of like being the chair of the International Agricultural Research System. It's a very big system. We had 11,500 staff. And within that complex of 18 centers at the time, then became 16 and others, there was always the feeling that IFPRI was the brains. It was the brains of the system. It was the institution that thought about policy for research and research for policy. Early on, they established magnificent achievements, including not only their 2020 vision, but also the technique of doing very detailed analysis and then writing very lucid, simple, one-page policy briefs that were widely appreciated by the many ministers and prime ministers and ministers of agriculture and other people that I dealt with around the world. So I hope that one of the things that you will learn in this seminar and this workshop here will be indeed not only how to do the analysis, but also how to communicate it. Because very frequently, we get bogged down into the details and we are unable to explain to policymakers and decision makers why our work is important and why the numbers that we have say that they should change their policies. And of course, they're thinking more about riots and people pressuring them and opposition groups in parliament and so on, and you're bringing them numbers. And this requires some translation. And that translation requires that you really understand what you are doing with the numbers and not simply crunching the numbers and saying, well, that's where the outcome result came out. And today, I understand that you are meeting over a very important topic, a topic that deals not only with the vagaries of climate change, and the impacts that we know climate change will have on a number of things, from rainfall to drought to rising in sea level to other forms of things, but how the interaction will occur with agriculture, both in terms of cropping patterns, in terms of the selection of the crops, both in terms of the traits and varieties that we should be looking for. And whether you're thinking in terms of that there should be breeding of plants that have shorter growing seasons, that have greater salt tolerance, greater drought tolerance, whatever it's going to be. Every one of those, of course, is a different thing. But the policy also of changing the cropping patterns in order to maximize the results is important. But then there's also the question, and why not change the way we plant the crops and change the traits of the crops themselves? And in every one of those, there are trade-offs. Aha. And that's where the modelers come in. They're very good at trade-offs. They can tell decision makers why certain paths of policy choices are better than others. And that is both in the short term, medium term, and long term. So this is quite a complex set of tasks that you are going to be addressing. And I know that the amount of work behind it is absolutely enormous. In fact, we had the pleasure not only of meeting with Clemens and his colleagues here in Egypt, but also we met with Perihan and her colleagues in Washington, and we had a chance to exchange views on many of these items. I will not take up much of your time, and I will leave Clemens to continue on this, but I do want to say welcome to the library. I do hope that this is just the beginning of a really fruitful collaboration between our institutions, and that we will do a lot more together. And I myself believe that we are on the cusp of a series of new revolutions that will impact agriculture and food. I've just finished serving on a very long panel for the National Academy of Science and the National Academy of Medicine, dealing with new gene editing techniques and when they should be applied to humans. That was the interest of the medicine, but the exposure that I had on the new gene editing techniques have made me aware of how it's going to make a lot of what we used to think of as genetic engineering seem very primitive. And this is much more precise, much more, and we will be able to zero in on particular traits. We'll be able to do a lot of things that we could not do before. Question is, we will need guidance in research, and that's where we always turn to IFPRI to help us have a policy for research as well as research for policy. So good luck each and every one. Welcome to the library. Dr. Noha Adli will be representing me in all of this. And Clemens, you are at home. And everybody, please consider the Library of Alexandria is your home. Thank you.
Okay, thank you so much, Ismail, for your kind words and also for your hospitality. I myself have been to the Library of Alexandria many times, including when I was young. I think I was here the first time in 2008, and my admiration has not changed. It has only grown because the Library of Alexandria covers so many different aspects of life, science, technology. It's really very impressive, and it's a great pleasure to being here. So thanks, Ismail and Dr. Noha, for making this happen. And I absolutely agree with Ismail that we are very much looking forward to working more with you in the future. So now I will be your moderator today. My name is Clemens Breisinger. I'm a senior research fellow and the country program leader of IFPRI in Egypt here. Just a few words about IFPRI. IFPRI is an international organization, a think tank, and our mandate is to provide evidence-based solution for reducing hunger and poverty worldwide. We're about 600 people globally, and we have just opened a new office last year in 2016, March 2016 in Cairo, and we are very happy to be here and to working with you, with the government, with universities, and other important stakeholders here in Egypt. So we are working on a range of things. They range from impacts of economic reform process. We are working on evaluating the impact of takaful and karama. We're working on agriculture and water. So a wide range of things, and today we are presenting together with the Library of Alexandria and also the Alexandria Research Center for Adaptation, ARCA, as well as the ARC, some findings and thoughts and evidence on how to make agriculture more climate smart in Egypt. For this, we have a distinguished panel, and I would like them to come up now and join me here. And then I'll introduce you one after the other. And I will start with Professor Mohammed Abdelkarim. But in the meantime, please, all panelists come up and join me here. So Professor Mohammed Abdelkarim is a professor of environmental economics at the Department of Environmental Studies, Institute of Graduate Studies and Research here at the University of Alexandria. His fields of interest involve environmental economics and socio-economic studies in environmental and urban context. He has been a consultant with many national and international institutions working on climate change and other things. So I would like to welcome you here to the podium.
صباح الخير عليكم. My presentation will be just taking a step back and looking at climate change. Most of the time when we talk about climate change, we talk about the environment and how climate change might affect some of the activities that we have and what will happen in 40, 50 years from now. Most of the work that has been done about climate change in Egypt was focusing on sea level rise and how sea level rise will affect the Nile Delta. And all the time, everybody was talking about by 2100, this and that will happen. As if on the 1st of January, 2100, people will wake up in the morning and find out that climate change has happened. And when everybody talk about climate change, they say, well, we're talking about the future, very far future. Why bother? We have already our own problems. Let's deal with them, and somebody else will take care of the future. What I'm trying to do here is to show that climate change is not an environmental issue. Okay, it's an environmental issue, but not just environmental issue. It's a development issue. And we'll see how this relates to sustainable development goals. First, I'll very briefly will talk about climate change impacts, vulnerability, and the concept of exposure. Then we'll talk about sustainable development goals and the interaction or the interface between climate change and sustainable development goals. And finally, how we should approach the issue of climate change and sustainable development. When we talk about climate change, well, according to the IPCC, we're talking about the changing climate. We're talking about a long-term changing climate. And either in terms of the mean or the variability of the climate system, which persists for a very long time. We're talking about decades or longer. If you look to the climate change definition by the UNFCCC, we're talking about a change of climate which is attributed directly or indirectly to human activity, which is altering the composition of the global atmosphere, again, for a long time, long periods of time. The difference between the definition of the IPCC and UNFCCC is about this component. It's about attributed to human activities, and the difference is due to the fact that the UNFCCC is about the Framework Convention on Climate Change, which means they're trying to figure out agreements about what should be done to deal with the issue of climate change, and thus they were focusing on the human component or human contribution to this problem. According to the latest IPCC assessment report, AR5, we're talking about a range of change in temperature according to the different scenarios, different RCPs. Now we start talking about 4 degrees and more. During the last report, the previous report, sorry, we were talking about mainly the maximum we expect that temperature will increase by 4 degrees. Now we're talking about 6 as being a possibility. In terms of sea level rise, again, according to the different scenarios, we're talking to up to 1 meter, according to the worst case scenario, RCP 8.5, 1 meter. The previous report was talking about 65 centimeters. So things are going up in the newest report, and also the newest report started talking about observations, about actual impacts of climate change happening in different places of the world. If we're talking about climate change impacts, you can just try very hard to identify a sector that will not be affected by climate change. If you're talking about coastal areas, if you're talking about marine ecosystems, terrestrial ecosystems, if you're talking about extreme weather events and their effects, impacts on livelihood, if you're talking about health, just name it, and you'll find that climate change will have some effects and some impacts on them. In order to understand that concept, I'll just show you the climate change impacts on coastal areas. What is expected? We're talking about sea level rise, we're talking about changing weather patterns and changing coastal dynamics. What does it mean? In physical terms, talking about inundation, saltwater intrusion, we're talking about erosion, ecosystem changes, we're talking about extreme weather events, we're talking about higher sea surface temperature, which means that the whole ecosystem, marine ecosystem, will be changing. In terms of socioeconomic impacts, we're talking about property loss or damage, we're talking about resettlement of people in some places, we're talking about loss of livelihood, we're talking about health impacts, we're talking about increased poverty. And you can go on with that list because it's a chain reaction to the primary effects. If we look to the urban areas, we're talking about temperature rise, which means heat stress, precipitation change, means water scarcity. We're talking also about air pollution in urban areas. We're talking about extreme weather events, which include flash flooding. We're talking about sandstorms, droughts, depending on the location you are in. We're talking about sea level rise. We're talking about coastal dynamics. We're talking about sea level rise inundation, saltwater intrusion. We're talking about the primary impacts. And again, the list would be much extensive if we start talking about secondary impacts. If we're talking about impacts on agricultural activity, again, we're talking about inundation, erosions, as I said, saltwater intrusion, water scarcity, extremes, changing water patterns, changing weather patterns. Socio-economic impacts, crop productivity will be affected, crop loss, changing cropping seasons. We're talking about loss of livelihood and increased poverty. We're talking about animal production will be adversely affected. We're talking about population mobility will increase from rural to urban areas. So this is the sort of impact that we'd expect in each and every sector that you can think of. But we have to keep in mind that the impacts are not uniform. Some of the impacts will be different according to the location that we're talking about, and not all of them will be negative. Some of them will be positive impacts, but unfortunately, most of the negative impacts will be in developing countries rather than developed countries. If we're talking about, for example, about warmer weather, for northern hemisphere countries, that's good news. In terms of agriculture seasons, cropping, and so on, that's good news. And also for less use of air conditioning and heating. Warmer weather would save on that. In terms of warmer weather for our southern hemisphere, we're talking about increased use of air conditioning, heat stress. We're talking about less favorable conditions for cropping and agricultural activities. So impacts are not uniform, as I said. They are not all negative. In some cases, they are positive. According to this map, which is in the IPCC AR5 report, you'll find that there are different impacts in different places of the world. That's the first observation. The second is, if you look to the Middle East, the Arab countries, unfortunately, there are no observations. It's not actually about no observation, but there's a lack of research to show that there are things that are changing. And as you know, the IPCC is not doing research by itself. It's just reporting on the research that has been done. And as I said, we always get the question is why the IPCC is ignoring the Arab countries. Well, actually, it's not about ignoring the Arab countries. It's actually about having enough research, peer-reviewed, to show what actually is happening. We are exposed to a lot of the impacts that we're talking about because of the location we are in and because of the economic and socio-economic conditions that we are in. The more vulnerable in terms of the socio-economic conditions, institutions, and so on, the more exposed you will be to the impacts of climate change. So, if we just sum up what we just said is, climate change impacts, we're talking about cross-cutting. We're talking about varied, not uniform, that they will magnify, they will put more pressure on the development efforts that we're trying to do. Therefore, we say that climate change is not an environmental issue. It's also a development issue. And if we don't deal with it like this, it means that some people working on the environmental aspects should take care of climate change. And it's not going to work. Finally, the worst impacts of climate change will fall on the poor. The more resourceful you have, the more resources that you have, the more resilient you will be. The less, the more vulnerable you will be. On the other side, when we talk about sustainable development goals, which was initiated in 2015 and supposed to be targeting 2030, we're talking about almost every imaginable aspect of development that we need to tackle, from poverty to hunger, health, education, gender equality, water, clean water and sanitation, clean energy, jobs, innovation, and so on. And also, it's about protecting the planet, life below water, and life on land. How this relate to the climate change? We can just show you that we are talking about a multi-stressors. We already have poverty, high levels of poverty. We have high levels of illiteracy. We have issues with health, and so on, jobs, economic growth. If you add to that climate change, with the system of impacts that we're talking about that will impact every imaginable sector, that means that we have a lot of challenges that we have, not just to tackle, to understand, to study, and to see how can we address them. There is an overlap between the two. As I said, Sustainable Development Goals, we're talking about no poverty, no hunger, good health, clean water and sanitation, good jobs and economic growth, sustainable cities and communities, protecting the planet. We're talking about protecting life below water and life on land, and finally, seeking peace and security. When you look to the other side, if you look at the climate change impacts, we're talking about extreme weather events, sea level rise, warming, changing precipitation patterns, water scarcity, decline in crop productivity, heat stress and waterborne diseases will increase, livelihood will be adversely affected, coastal erosion and marine terrestrial systems and marine and terrestrial systems will be adversely affected. Look to the two sides. I have to say that at the beginning I was trying to create some sort of links between the two sides to show the sort of overlap between the two of them, and I failed. Because if you take each and every one of the climate change impacts, it will affect not just one or two, but most of the list of the Sustainable Development Goals. So, how should we approach the issue of climate change and sustainable development? There are different ways to go about it. First, we can go for the sectoral adaptation option. Each sector should start looking for the adaptation options that would help to adapt to climate change impact on that sector. The problem here is some of the adaptation options that some of the sectors will consider will actually have adverse impact on some of the other sectors. That's the first. We can talk about sustainable development again at the sectoral level. Let's talk about the economy, let's talk about tourism, let's talk about agriculture, water, and so on at a sectoral level. Again, there are conflicts. It's not a win-win situation. We can talk about integrated adaptation approach. We have a strategy, a national strategy for adaptation to climate change, and work alongside other activities in terms of development and other goals. But again, they will not match. What we actually need is to have as an integrated sustainable development climate change strategy. Climate change should be part of the sustainable development strategy, should be part of it, not run parallel to it. They should be running together, taking into consideration the sort of impact and interaction and overlap between them. So we have to reconcile climate change risk management and development. We have to integrate adaptation mitigation policies with the sustainable development strategies. If we're talking about development, we should start thinking about the green economy. Some people think that green economy means that we have to be green in terms of the color or in terms of crops and so on. Well, actually, green economy means that we're talking about an environmental friendly economy. It's about how to utilize the resources that you have in a friendly way to the environment while generating income, generating job opportunities, and so on. I'll just give an example in this. If we're talking about solar energy, in Egypt we're talking a lot about energy. We're having a problem with energy. During the last year, Morocco invested heavily in solar energy and created the biggest solar stations in Africa. They are aiming to satisfy their energy requirements through solar energy, and the second phase would to export the electricity that would be generated from the solar energy to Europe. That's green economy. In this, our center, Alexandria Research Center for Adaptation to Climate Change, I'm not saying that we are doing anything other than we're trying just to move forward with some of the work in terms of research capacity building and so on. We went through 3 phases so far. We started in 2011, and for the first 3 years, our focus was on climate change, the fundamental concepts, awareness, trying to support researchers to get into this. The second phase, we moved a bit with the capacity building. We started to move in more advanced in terms of climate change and different disciplines. We tried to support different stakeholders like WEAA, like some of the universities. And we started publication because one of the things that we have to believe in, having the information, data and information in itself is not enough. It's not about collecting information. If you don't use it, it's a waste of money. So what I'm trying to do is we'll try to keep all our materials, publications, papers, reports, and so on, available online for whoever is interested in that material, and whoever is interested in other materials that we have, we can provide support as much as possible. At this phase, we'll try to do some networking at the national and the regional level for the climate change work. In this respect, we're starting this year, academic year in September, climate change and sustainable development master degree. It's not about people attending a workshop or a couple of workshops, and they will be actually able to work in the field of climate change. That need to be over a longer period of time and covering a number of topics in this respect. We have in that master degree, we have scientific research skills, we have core courses. We're talking about people from different disciplines. As I said at the beginning, that climate change is not going to affect a sector or a number of sectors. All sectors will be affected. So we have a number of courses, core courses for students to start with, and then optional courses depending on their line of research and discipline of work. We believe it's a step. It's not a big one, but just a step trying to move forward in that direction, because the problem that we're talking and the gaps that we have in Egypt, actually, it's the same as what's happening in other Arab countries in general. Thank you.
Okay, Professor Mohammed, thank you so much for this excellent overview. And as you have rightly said, the impacts of climate change will be severe, but they will also vary at country level, even subnational level. They will vary across sectors. They will vary across even households to some extent. And I think you're absolutely right. One of the tasks of us today and in general going forward is to fill this gap in the global map, no, where the MENA region is underrepresented in terms of research. So I see this event today as one of the steps to close this gap. At the same time, and coming back to Dr. Sarah Geldin, it's also very important to not only look at the channels, but to also add numbers. What exactly, yes, we know there's an impact on yields, but what is the impact on yields? Even what is the impact on different types of yields, maybe in different parts of different countries? What's the impact on the macroeconomy? What's the impact on households, etc.? And these questions we will start to answer today with our distinguished panel. All of them have a very solid technical background and use quantitative methods. But before we come to the more quantitative results of the studies, I would like to now invite Professor Mahmoud Atef Sayed. He's representing the Agricultural Research Center today. He is in the Water Requirement and Field Irrigation Department. Thank you very much for coming over, and the floor is yours, please.
As Dr. Al-Magid talked, the sea level rises, impacts higher temperature, more extreme heat, low precipitation, more severe storms, more floods, more drought, that also affect the agriculture practices. Most vulnerable situation national River Nile storage or capacity or the amount of water will be less. Water resources usage will or can be distributed as agriculture sector, 95% or 95% will be less. The industry sector will be higher, about 7.9 billion cubic meter. Navigation will be higher. It's 1.8 billion or million cubic meter. Houses sector will be increased. Extreme events in Egypt. The sea level rises will, in some models, our delta, part of it will be merged with water, with sea water level. We have some floods of water. So floods first will be event, hails, hot waves, like we have now. Global goals of climate smart agriculture. Achieving food security, hungry, poverty. Adaptation of climate change critical will be would be used to lose أو to نخفف عن ال climate change effects. Avoiding dangerous climate changes will be also needed. And these factors are overlapped. Action, and we say yes or no. Increasing productivity, yields per acre. Yes, we need them by some varieties, new varieties, to improve the productivity of the yield. Effective water use, we need researchers to use we need short period crops to reduce the water required for crops. Agriculture must be climate smart. Sustainability, increase resilience, adaptation, reduce greenhouse gases where possible, and enhance the achievement of national food security. Sustainability, increase productivity by introducing new varieties, increasing resilience, adaptation, reduce, remove. Climate agriculture, climate small technology, climate information services, indexes based insurance, local adaptation plans, and we can use parameters or models to upscaling. Practices, climate smart practices exists. Ecosystem approach, investment are needed in finding data, R&D of technology, conservation. Key message to small householders need instituent and financial support for transition. Breeding and consistency between agriculture, food security, and climate change policies. Message 3, available findings, current and producted are sustainability insufficient. Combining finance, public, private, climate, changer, food security improves options. Fast-track findings or financing must take actor, a specialist, a specific consideration into account. A mitigation on scope of agriculture, it is not only about soils, vegetation. In agriculture, landscape has a very large potential. Emission reduction per produced units will be a major technical component. Increasing water productivity. Increasing water productivity by the irrigation methods we used. If we use a high efficient methods, like ditches, will save about, like this picture, will save about 20% of the applied water. That's improving water in the Nile Valley, on all the land. This is all agriculture or irrigated lands, all the land. We will use modern systems to improve the efficiency of the water, of the applied water. We can irrigate every row and leave the second row. We can level the soil. We can make trenches or beds, wide beds, to improve the water efficiency. Introduce new varieties of crops, vegetables or fruits. We can use Sakha 107, Sakha 103, sits مصر واحد for wheat, Giza 179. Modernized irrigation, modernized agricultural practices like leveling the land, using machines to make ditches or make wide trenches, use a new varieties with short periods, use soil conditioners to improve the water holding capacity, adaptation needs. We saw in Ismailia a few years ago, the mango trees are affected by by rains, and all the high trees are died. But the farmers who use the short dwarf or dwarf mangoes are alive the trees. Thank you for.
All right, so thank you very much, Professors Mahmoud and Mohammed, for your very good overview of climate change impacts in general and climate-smart agriculture concepts in Egypt. Now it's my great pleasure to introduce to you three young climate scientists from Library of Alexandria and from IFPRI. They will be talking to us about their findings of their quantitative and very rigorous research. And we will be looking at this at three different levels. So Perry will be the first one, starting with the results of an economy-wide model to see what is the expected impact of climate change on the macroeconomy and at the more sector macro level. And then after Perry, we'll move down to the agricultural sector and eventually come to more household level kind of adaptation strategies. So I'm very excited to have this young dynamic panel here with me. And so the first one to speak to us is Perry. Perry is a senior research analyst at IFPRI in Washington, D.C. She has held several positions before she joined IFPRI in 2009 with the various international organizations. So it's a great pleasure to have you, Perry. Please come up, and the floor is yours.
Thank you, Clemens, and for the introduction, and thank you very much for calling me young. I will very gladly accept this, this adjective. I also would like to thank everyone here. Alexandria is my birth city, and it holds a very special place in my heart. So I'm very happy to see all of you, and thank you for giving me the chance to speak, especially to the Bibliotheca. So let me just share with you some results of ongoing or in-progress work that we have been doing recently at IFPRI. Really, it's part, what I present to you today is part of a larger project which attempts to assess the impacts of the water, food, and energy nexus on Egypt. But today I will discuss with you the preliminary results that we got as a result of that study on the impacts of climate change on Egypt. We focus on the agricultural sector, but we also are able to give some insights to the rest of the economy, again, in Egypt. So just a little background, we used the data set that we use, our initial year is 2010-11. And just to put everything in perspective to that year, this is the breakdown of GDP at factor cost for Egypt in 2010-11, where you see that agriculture comprises around 12% of GDP at factor cost. The share of agriculture in GDP has been falling over the past several decades. This is a fact. And as you can see, the breakdown or the structure of the economy at that time. Once again, if we take another look at the macro variables and try to place agriculture in the macroeconomy in Egypt, again, you'll see that it comprises, the 12% of GDP at factor cost. It contributes 9% to total production in the economy, provides 16% employment in the Egyptian economy, contributes 6% to exports and 10% to imports. And the export-output ratio of the agricultural sector, which is the what is produced and then exported, is really, you will see, is a little bit low, meaning that most of the agricultural produce that we produce, we do not export, we actually consume domestically. So this is just, again, the major sectors in the economy. And the reason I stress this is I come back to this later when I show you the results, the preliminary results that we got from assessing the impact of climate change on the Egyptian economy. So let me talk just a little bit about the modeling suite that we used. It's a hybrid modeling framework. We decided that each model is well suited to actually represent its strong points, its strengths. So we use a framework that's made up of 3 different models: a hydroeconomic model, an energy model, and at the center of all of that is an economic model, which is a computable general equilibrium model. That really is very strong in showing the interlinkages that exist between the sectors in an economy and the agents also represented in that economy. So for instance, the hydroeconomic model is made up of a hydrological model and a river basin and crop model that both give us yields, crop yields through 2050, and we're able to use these yields that use GCMs, and we can project, not project, but we can actually use these yields to see how the economy will look like in 2050. So these are the GCMs that we have used for this analysis. We focused on 6 climate models. And the reason we chose these 6 is they are really the intersection between IFPRI's impact model, the scenarios used in IFPRI's impact model, and because we used some of the data from the Nile Basin initiative, these are also the same 6 scenarios that are used in the Nile Basin methodology or framework. So these are intersection between what IFPRI is using and what the Nile Basin is using. And again, because we prefer not to give results on just based on only one GCM, we try to, as much as possible, capture the variation that exists in these different GCMs, and hopefully we can give a range of results as using these models. So first of all, we use the IFPRI impact model that gives us a forecast of the global food prices. And these are just some of the major crops that the impact model gives us forecasts for, specifically the prices. Again, we're using the same 6 GCMs that I had mentioned earlier. Now, these are some of the crops that are in our database for Egypt. And you can see that for some, you have increasing global prices. For some, you have decreasing global prices. And for some, you have increasing global prices, but at decreasing rates. And all of these will counter into the results that we get at the end. So these are the different yields that we get from these GCMs. And our base scenario, or our main scenario that we compare to, is a scenario that we called no climate change. And for this scenario, we assume that nothing happens. There is no climate change. We have a baseline and a trajectory that goes out to 2050. But at the same time, we acknowledge that somewhere outside of Egypt, on the global market, world prices will change. And so we use those two points, or those 2 extrapolations, and we have the scenario against which we measure all the different climate change options that come up from the global climate change models. So the one on the left, no climate change, right here. Oh, I can't. This is what you will see, all the results of the impacts compared to in the diagrams that are coming up. As you can see, just taking a very quick look, you will find that, for instance, maize and sorghum yields are going to be decreasing over time, regardless of which model we use. Some will decrease more than others. At the same time, if you take a look at cotton also, these climate models predict that the yields for cotton are going to decrease over time until 2050, which is our timeline. So just taking a very quick look, you can sort of guess where we're going with those in terms of yields. So in general, remember the first table I shared with you, which actually breaks down the sectors and their contribution to the Egyptian economy. Agriculture contributes 12% to GDP. It contributes only around 3% to exports. So really, as I had mentioned, agriculture has been decreasing, or its role or its intensity has been decreasing in the Egyptian economy over time. And so we found in our preliminary results that the climate change impacts are not going to be as intense on the macro indicators, especially here GDP. Now let me explain and what exactly those two scenarios that we deal with. Now we're the local climate change impacts, which is the graph on the left. What we say is, okay, yields of crops in Egypt are going to be decreasing. So we use that information and we go ahead and we run our model. The other scenario is we assume that not only are yields in Egypt going to be decreasing, but we also acknowledge that global prices for agricultural goods are going to be changing over time. And this is a scenario that combines those two. So not just the impact in Egypt, but also the impact in Egypt, taking into account what is happening on the world market. So at least right now, with these 6 scenarios, we'll find that our results show there's not much change. Now, there's an increasing, in general, GDP will be increasing, but there's not a lot of variation at the macro level. But that does not mean that change is not happening. I'll just dig down a little bit deeper, and I'll show you where the change is happening as a result of climate change. Now, let's take a look at agricultural GDP impacts of climate change. Again, I'm using these same 2 scenarios, only looking at local yield changes and looking at the combined impacts, which is local yield changes and assuming that we have global changes in agricultural food prices. You'll see here that there is, now the red line is, remember that baseline I told you? I told you we were always measuring against, the no climate change scenario. This is the heavy red line that is right there on top of the figures. Now what that tells me is overall agricultural GDP will be increasing, right? Because we are showing positive percent changes over the years. However, if you look, you'll find a gap between the red line, the very heavy red line, and the rest of the lines. Now, the rest of the lines are the different climate change scenarios. So even though agricultural GDP will be increasing, however, because of climate change, it will not be increasing as much as it would have increased had there been no climate change. Okay, so you can clearly see that even though there's not much change happening at the macro level, however, when we focus on the agricultural sector, we find that no, the agricultural sector is, of course, being impacted. Now, if we dig down a little bit deeper, and we know that for the agricultural sector in Egypt, around 50% of its value added comes from the livestock sector, and the rest really comes from the crop sector. So if we take a look, I actually compared, I took a look at the livestock sector and the crop sector. Livestock sector, not much change really has been happening. However, the changes that I've shown you in this diagram in overall agricultural performance is being driven by the changes that are happening in the crop sector in Egypt. You'll see here that the discrepancy between no climate change and the different climate change impacts is even more intense than if we look at only the agricultural sector as a whole. So what does that mean? It means that as a result of these different signals that the agricultural sector is getting, we will find that resource allocation will change, right? So if we take a look at the left, again, we're only looking at local climate change impacts. You'll find that land allocation, and this is an average annual, so we actually took the change over the entire period from 2011 until 2050 and averaged it out over those 40 years. And what you're seeing here is for each scenario, the average annual change in land allocation. So you'll find that predictably for crops that show negative yield changes over time, land will be allocated away from these crops to the more productive or the higher yielding crops. So there will be resource allocation impacts in our case. And you'll find that, again, the very heavy red line is the baseline, which is in the event of no climate change, and all the others are the variations in the climate change scenarios as a result. And on the right, again, it's the combined climate change scenario where we take local yield changes in addition to global price changes, and we look at the impact on both. Now, you'll see that in general, and throughout all the scenarios, you'll find that the adverse impacts of climate change, when we only look at local effects, is a lot greater than when we look at the combined climate change. And the reason for that is really very simple, because mostly crop prices are going to be rising in the future globally, then this will have a positive impact on the agricultural sector. If we just look at, prices are rising globally, then net producers of these crops in the agricultural sector will benefit. They will have higher incomes. And so this actually ends up being a sort of a slight buffer to counter a little bit the negative impacts of yield change or yield declines for some of those net crop producers. So that's why you're saying, even though for those same crops that we see negative yield changes over time, the negative impact is a lot less when we factor in that globally prices will be rising for these crops on the global market. It's not enough to completely eradicate the negative impact, but it does lessen the negative impact. Now, if we take a slightly, one of the indicators of welfare here, I plotted the rural households, which are in red, the red bars, the urban households, which are the orange bars, and all of the households, the yellow bars. And this is household spending, which we will take as a proxy for welfare or household welfare. You'll find, again, using the same two scenarios, only local yield changes or only local climate change and combined climate change impacts. Now, it's not a dramatic decrease, as you will see, and again, it's an average annual, so we actually averaged across the entire period, just so I can present all of the scenarios here in a not in a busy figure for you. So you'll see that, again, the no climate change scenario, of course, people are better off when there is no climate change, and they are slightly worse off when there is climate change. Now, again, the difference is not huge, right? It's still very not as much as we would have expected, but please bear in mind that this analysis looks really at households at the macro level, right? And the more you dig down deeper, which hopefully my colleagues will be showing, the more you will be able to actually see the impact on these households at a finer or a more detailed level, okay? But clearly, it does show that if we take that as a welfare proxy, climate change in the future will adversely impact welfare, or one proxy for welfare in the Egyptian economy. Now, we didn't just stop at the climate change impacts, but we went ahead and said, okay, so now we know climate change is happening. We all know climate change is happening. So what do we do? How can we actually intervene in the economy to try and try to mitigate some of these adverse impacts of climate change? So again, as I said, this is still a work in progress. So we looked at trying to intervene in two sectors, the water sector and the food sector. The water sector in Egypt, of course, is really the water supply and distribution sector. The food sector we took to denote not only the agricultural sector, but also the food processing sector. Again, we assessed so we started with saying, okay, climate change is happening. What happens if we try and intervene through policies to try and lessen the impact of that climate change? So we ended up with these are the water sector interventions. We assumed that according to Egypt's Sustainable Development Strategy for 2030, they are saying that they want to try and improve the productivity of the water sector by around 5% per year until 2030. So we took some of the numbers from Egypt's Sustainable Development Strategy, just as an example, just as preliminary results. We know that at the field level, efficiency or water use efficiency is not at its optimal. It's quite low. And the strategy actually says that this is one of the objectives that they want to achieve, is to improve water use efficiency at the field level. And so we actually used that scenario in the water sector. And finally, we said, okay, what if we do both? What if we, we have increasing productivity in the water sector and we have more efficient water use at the field level? Then what would we find at the, what impacts will we have at the economy? And for the food sector, we said, again, the strategy says that the government of Egypt is looking to expand horizontally and vertically the production of food. And so horizontally by reclaiming more lands, the 3.1 million faddans, and vertically by increasing the productivity of crops or of the agricultural sector in order to expand vertically. At the same time, the plan also looks to increase investment in the agricultural sector and also in the food processing sector as a way to not just boost manufacturing, but also to boost all the backward and forward linkages for the agricultural sector. So we went ahead and we did that, and I just want to show you just one or two slides, really. Again, they're very preliminary results. If you take a look at agricultural GDP, the two top ones, again, same scenarios, local and combined, but with only interventions in the water sector, you'll find that, yes, there's still that discrepancy. So the water sector by itself doesn't really help much in closing that gap between climate change and the baseline. But if we take a look at interventions, for instance, in the food sector, with the food sectors, which are the bottom two graphs, we'll find that it could be possible that in addition to increasing or expanding horizontally and vertically and increasing investment in the food sectors, we may be able to actually mitigate some of these adverse impacts of climate change. And so these are just very preliminary results. Eventually, we're going to refine these results, and we're going to introduce also the energy sector into the mix, because remember, our framework is a hybrid modeling framework. And by the way, outside the discussion paper outside shows all the methodology that we use for that modeling framework. Now, the main findings, just as my very distinguished colleagues previously mentioned, we know climate change is happening. We know that there will be negative impacts on the economy. From our studies, it shows that, yeah, the yield impacts are negative, but there are variations amongst the crops. As an example, pulses, oilseeds, and cotton. And then there are also local and global impacts. So globally, prices are expected to rise for agricultural crops, and locally, each country will have its own local impacts of climate change. At the macro level, I will say this with a grain of salt. Egypt may be slightly more climate resilient than we expected. It doesn't mean that climate change is not impacting Egypt at the macro level. However, because currently the agricultural sector is a relatively small share of the economy, then there may not be that many spillover effects as large as we would have thought to. However, of course, there still will be negative impacts. It's just that if the sector starts shrinking, then really the negative impacts will not be as much as we thought on the macro level. There is a noticeable effect on the agricultural sector because, as we can see, there will be a reallocation of crop mixes, right? Farmers will be growing those crops that are more profitable for them. So within the agricultural sector, you actually find quite an intense movement in reallocation of resources within the sector, so at the subsector level. The CGE model in general gives a more aggregate analysis on household welfare, and that's why we need more detailed models that are able to look at the household levels at a much greater detail than the CGE model can give us. But it does show you all the interlinkages between the sectors and the economy, the outside world, and the different agents, producers, and consumers in the economy. So thank you very much.
Thanks a lot, Perry. I think you have clearly demonstrated the value of quantitative analysis and also using models, because they do put numbers on some of the assumptions or the general thinking that we have. We can always argue about assumptions and scenarios and numbers, but really the great value of this kind of work is that we have something to argue about and not just talk about vague kind of possibilities, but we can clearly say, given X, Y, Z is true, then ABC may happen. And so I think really this is what we call an evidence-based dialogue, and that is, I think, what we need to do more. Now, having said this, it's a great pleasure to welcome Nada Kasim to the panel. She is a research assistant at the Library of Alexandria's LEAR initiative, and she's one of the lead authors of the forthcoming publication on impacts of climate change on the optimal crop mix in Egypt using a crop optimization model. Nada, thank you very much, and the floor is yours.
Thank you, and I just find it fits perfectly that my presentation is right after yours, because we've been inspired by IFPRI, and you will find several similarities, but we will dig deeper into the micro level. So first of all, Dr. Ismail has already mentioned our institute. We conduct quantitative modeling on several research disciplines, but we have started with the impact of climate change, and we've explored different possibilities, socio-economic sectors that we can explore, but at the end we opted for the two essential sectors, water resources and agriculture. According to the UNDP report conducted in 2013 on the potential impacts of climate change on the Egyptian economy, under the most pessimistic climate change scenario, agricultural production would decrease by 11% and prices would increase by 29%. So agriculture would be gravely affected by climate change to some extent, from a micro point of view. In order to reduce the negative impacts of climate change, several adaptation techniques have been proposed, among which the shift to salinity-tolerant crops, as well as the reduction of crops that use high water consumption. But we have explored a different option, which is crop mix optimization. We believe it's a feasible and efficient tool that would lessen or lighten the negative consequences of climate change. Crop mix optimization aims at establishing the best set of crops to be cultivated at a certain area through a certain period of time. In order to achieve this, models are developed that serve several purposes, among which maximization of net revenue, minimization of fertilizer use, or the minimization of water use. In our case, we modeled the optimal crop mix in Egypt under different climate change scenarios. My presentation will be structured as follows. At the beginning, I'm going to illustrate the model, then I'm going to show you the output, and at the end, the conclusion and future work directions. It's still a work in progress. We have results and everything, but we need to enhance and refine the model and to do some fine-tuning. Okay, so first of all, the crop mix optimization model. As I've already mentioned, it aims at maximizing the net revenue. And the decision variable is the cropped area for a particular crop C at a given region and at time T, or at year T. The model is represented as a net revenue maximization equation that is calculated using such variables such as yields, prices, costs, water consumptive use, water available for irrigation. But it has to be constrained and restricted. So it is also, some constraints are reflected as well. And first of all, there are two basic constraints, which are the land use and the water use constraint. And when it comes to crop mix optimization, they are just essential. The land use constraint implies that the sum of areas allocated to the different crops cannot exceed or be equal to the overall presently available arable land. The water use constraint is similar. It indicates that the sum of irrigation water consumed by the crops cannot exceed or be equal to the total available water for irrigation. Now, the cropped area constraint. We've been inspired by several papers, but we've developed it. It's a very practical constraint. It's important because in reality, the cropped area of the different crops cannot change at an instant, not from one time period to the other directly. So what we do is we add a delta A. Delta A is the percentage of change that can be changed through a period of time, or that can be altered through a period of time, which means that I can tell you it's easier to illustrate it in our case. So for the experiment I'm going to show you, it's very flexible. We can adjust it, but for the experiment I'm going to show you, we've used 25%, which means that 25% of the area of the different crops can be changed through every period of time. And in order to calculate this value, or the percentage of what, we take the average of a couple of preceding years, the average of the cropped area of the couple of preceding years. So in our case, we took 4 years. So the cropped area can be changed by 25% above or below the average of 4 preceding years. Another important constraint is the wheat self-sufficiency constraint. In our case, we have conducted 2 runs, or we had 2 sets of constraints. One where we had a wheat self-sufficiency constraint, and one where we didn't include it. And namely, the important thing is that wheat is the most important grain crop in Egypt, and grains are in turn the most important crop group in Egypt. So since the 1960s, there has been a wheat self-sufficiency constraint, and we've tried to represent this in the model. So we observed wheat data, wheat production and consumption data, historical data, and we have remarked that it fluctuates around a value of 50%. So what we've done is that we set a minimum bound for wheat. It cannot go under 50% of the production of the consumption of wheat. But we had 2 cases. So we just wanted to reflect the reality, but this doesn't mean that there has to be a wheat self-sufficiency constraint. Okay, and we have implemented the model on 26 crops, which are to some extent very important economic crop for the Egyptian agriculture. But trees and palm dates were not included, and crop rotation and intercropping were not included either. This was mainly due to data availability on the one hand, and on the other hand, they would increase the model complexity. So for the moment, we haven't included them, but they will be included in further research. Another important aspect that we believe is inevitable is seasonality. Throughout the process, we've noticed that without working with seasonality, the whole run or the whole model is lacking a very important aspect. And so we have tried adding it, but the problem is the data availability, because if you can imagine, there are 6 variables, and we need, for the 26 crops, data about the different seasons. So we're trying to gather the data and then we'll add it. But for the time being, we've used a proxy for this, namely that we've used the cropping area, not the cultivated area. And the cropping area is defined as the cultivated area in the 3 agricultural seasons. Okay, so now that we've defined the model and the assumptions, the time frame. The model runs from the year 2013, which is our base year, to 2030, which is the projection. It iterates on an annual basis, but it's a flexible model. We can make it annual, we can make it month or seasons. And we intend on going into in-depth. Okay, so first of all, the base year 2013. I won't go into details as to this part, but what I can say is that we wanted to validate the model, so we have made a run of the year 2013, compared the values we obtained from our model, the cropping area values, to the values that, the actual values that were planted in the year 2013. What we've noticed is that some crops increased, some crops stayed the same, but at the end of the day, the model achieved several of its purposes, which are increasing the net revenue, reducing the water use, and increasing the productivity of profitable crops. We've tried to do the same at the regional level, and we were able to do it on the base year. So we conducted a base run to generate the optimal crop mix of the 5 regions in Egypt, and have conducted a base run on the base year 2013. What we've noticed is that as we go finer in granularity, the data the results become more accurate. But the problem is, as you will see, we have a projection, and we weren't able to do the same for the projection because of the data needs. But we have noticed that it's essential in many aspects to add regions. So seasons and regions have not been added yet in the projection, but will be hopefully soon. Okay, so now the projection. First of all, the climate change projections. It's been mentioned previously, but I'm just going to tell you what we've used. And we have used 2 general circulation models, which are Institut Pierre-Simon Laplace, IPSL, as well as the UK Hadley Centre for Climate Prediction and Research Global Environmental Model, HGEM. So we used 2 general circulation models, 3 representative concentration pathways, RCPs, as well as 3 socio-economic pathways, SSPs, and together it was like the 3 RCPs together with the 3 SSPs made an optimistic, a moderate, and a pessimistic scenario, and at the end they were conducted on 2 general circulation models, so we had 6 scenarios. And we had 6 scenarios, 2 constraint sets, so at the end of the day, the constraint set without self-sufficiency and the one with self-sufficiency. What's important to mention here is that the results I'm going to show you in a few are all the normal case, or the no self-sufficiency case. At the end, I'm going to show you a comparison with the with self-sufficiency case. Okay. So first of all, I just need to say this very briefly. Because our projection is up until the year 2030, the temperature increase isn't enormous. It's just a 2 to 4% temperature increase, and the differences between the different GCMs aren't enormous either. We've also observed the differences between the optimistic and the pessimistic scenarios, and they were less than 2%, which is mainly attributed to the fact that we're looking at a short time span, and additionally, most studies predict temperature change or boost to be mainly after the first half of the 21st century. So we need to keep this in mind because this will affect the projection heavily. And this is the bulk of our work, or the most important part, which are the projection methodologies. First, you'll find the sources and the projection methodologies we've used, as well as the validation. In this regards, we need to thank the Ministry of Agriculture Economic Affairs sector, the Ministry of Agriculture Agriculture Research Institute, the Faculty of Agriculture at the Alexandria University, ARCA Institute, as well as the CAPMAS for providing us with essential information, material, and data without which we couldn't have conducted the research and we couldn't have had any results at the moment. So thank you very much. Okay, so the first part of the projection is the cropping area. The cropping area, we gathered historical data and we conducted a time series regression, and we've noticed that the 26 crops account for 74% of the total cropping area, and we projected to 2030. In order to validate whether whether this corresponds to the Egyptian government. We have compared it to the Sustainable Agricultural Development Strategy towards 2030, the SADS, and we've noticed that there is a slight difference between the two projections, but at the end of the day, they are close. And I'm going to explain the reasons for the difference at the end of the presentation. Now, the crop water consumptive use is defined as the water use for the crop from the time of planting until its harvesting date, and we have projected it using the CropWatt software that was developed by the FAO, and it is based on different modules concerning soil, climate, and crop management. As you will see, crop water consumptive use increases through time. However, if you look closely, the increase isn't as enormous, and it's mainly attributed to the temperature change that isn't huge either. Now the prices. Okay, so first of all, we had two steps in the price projection. First of all, the hypothetical no climate change scenario that is similar to that of impact. We gathered historical time series data, and we have conducted a time series regression. And at the end, what we got at the end was the domestic Egyptian prices projection. But this alone didn't reflect any of the climate change scenarios. So what we've done is we've used impact, the IFPRI's model, and in this regard, we need to thank IFPRI very much. Dr. Ismail has mentioned before, we visited them in Washington, and they were very helpful, and without their inputs, we couldn't embed the price projection in the model, so thank you. And the second step was to establish a statistical relationship between the domestic prices we've projected using the historical yield regression and the world prices that are projected by impact. And upon establishing this relationship, we were able to have a full price projection of the 6 scenarios. And as you can see, the prices increase, and Perry has already mentioned the reasons for this increase. And yes, so prices of all crops increase throughout all scenarios. We have treated the costs similarly, but we define the cost as production, transportation, and irrigation cost. We have exhausted all possibilities to find any precedents that models the costs in any kind of way to the future, but we weren't able to find any. So what we've done is that we have done something similar to the prices. We projected a no climate change scenario for the costs, and then we applied the crop-specific growth rates that were projected by impact to the domestic or to the no climate change costs that we already have obtained. And this is how the costs look like. Then the yield. We have explored the possibility of using biophysical models that simulate plant growth and that are process-based and are very detailed, but the problem is they need very detailed data, like for example the soil and water runoff, and as well as soil temperature, nitrogen level, among other, and we couldn't obtain this data. So what we've done is that we used an approach also inspired by one of IFPRI's team members. It's called historical yield regression, and what it does, it has 3 main parameters, or it can be more, and what it does, it follows a statistical approach of yield projection. So the dependent variable is the yield, and the explanatory variable is the weather data, prices, as well as the trend of the yield. And at the end of the day, we project the yields to the future. So at the beginning, the steps we went through were obtaining the historical data and then putting the projected weather data, obtaining the historical weather data and then putting the projected weather data with them, and then the same thing for prices and the same thing for yield, and at the end of the day, we projected the yield under different climate change scenarios. And this is how the yields looked like. Our only concern to some extent was that not a lot of crops have exhibited a decreasing trend, but rather most of them increased, and we were able to justify this by the fact that we are looking at a short period of time. Concerning the water available for irrigation, we've also exhausted several possibilities, but the problem is that we haven't found any precedent that models the water available for irrigation. So at the end, we opted for a literature review that indicates that the Nile River Basin will not, or the water available for irrigation in the Nile River Basin won't be altered before the middle of the century. And so we assume that the water available for irrigation will be constant from 2013 till 2030. But the value we gathered was the result of a multiplication of the water consumptive use times the cropping area. And this is the same methodology that CapMass uses as well. Okay. Now the output. Okay, so generally speaking, this is how the output looks like. And well, the crops that increase are watermelon, sugar beet, tomatoes, one-cut clover. And the crops that decrease are cotton, maize, rice, and onions. We didn't find it extremely logical, or we weren't able to justify it at the beginning why the cotton and the maize decrease. But as Perry mentioned, it's not maize and cotton are important crops for the Egyptian agriculture, but sort of they do not have a comparative advantage in these models. They are not high in yield, they are not extremely high in net revenue, and I'm going to explain to you how the whole thing is calculated now. We haven't found any very huge differences between the two scenarios, so the only difference between the pessimistic and the optimistic scenario was the potatoes, namely it rises in the pessimistic scenario. Perihan has also mentioned this concerning the GDP, in our case the net revenue. The net revenue increases. This doesn't mean that climate change will have positive impacts on the country, but the model in this case has achieved a big part of its goals, which is the maximization of net revenue. Okay, so upon interpretation, what we've arrived at is that there are 6 or 5 clusters which can be identified, namely crops that generate high net revenue but consume low water for irrigation. These are the best set of crops, and watermelon and garlic are, in our case, the only crops that fall in this category. There are other crops that are also profitable due to the case of the water scarcity, which produce average net revenue but consume a very low amount of water use, which are one-cut clover, sugar beet, wheat, among others. And there is a group of crops that produce very high net revenue but use very high water consumptive use. And in this case, the model, there are several crops in this group, which are tomatoes, onions, eggplants, sugar canes, cotton, among others. But the model was not able to favor any of the crops in this group other than the tomatoes, which is mainly due to the fact that we have an issue of water scarcity in Egypt, and the model is restricted by water. So at the end of the day, the model couldn't plant more of this cluster. And we have a cluster that produces low net revenue and uses low water consumptive use, and at the end we have a cluster that doesn't have a comparative advantage. What does it mean? Maize especially is average in everything. In the concerning the net revenue, it's very average, and concerning the water consumptive use, it's very average. So the model sort of wasn't able to favor it. But we were a bit unsatisfied with the results, so we thought of maybe enhancing it in a different way in the future. So these are the results. Yes, and this is the wheat self-sufficiency constraint. As you can see, there are some differences, some huge differences, especially in the wheat. What we have to say is that the net revenue increased by 13%. We had just one small problem, which is that several crops increased upon adding the wheat self-sufficiency constraint, which was, in our case, very weird. But we thought that maybe when we add the seasonality, the winter crops will be competing with the wheat, and at the end of the day, the model will decrease winter crops and increase summer crops upon adding the wheat self-sufficiency constraint. I have mentioned the SADs earlier, and in order to see where we stand from the government policies, we have made a comparison of the optimal crop mix, of our proposed optimal crop mix with that of the SADs, and we have noticed differences, but it is mainly due to several underlying conceptions that are different in both cases. For example, the SADs assumes a raise in productivity in several crops, lowering of water consumptive use, as well as a drastic increase in land reclamation. It also, the total number of cropping areas in 2030 arrives at 23 million faddans in the SADs, and in our case it arrives at 19 million. So this difference also shows why the cropping areas are allocated differently. Additionally, in 2030, wheat self-sufficiency shall reach 80% according to the SADs, while in our case it's only 50%. It is remarkable that there are some aspects, some crops that are close, which, for example, onion and wheat, but there are differences which we don't know if they are correct, for example, maize and rice. Okay, before we conclude, I just want to show you a a visualization tool that we have developed. It summarizes all the aspects that I've talked about previously, the trade-off between the three parameters, yield, water consumptive use, and net revenue, as well as the cropping area. And it shows you how the model operates to some extent. So you will see the development of the different crops. On the x-axis, you can see the water use. On the y-axis, you can see the cropped area or the proposed area by our model, and the size of the bubble indicates the net revenue. So whether it's high in profitability or low. And I'll let it play now. As you can see, wheat is increasing, multi-cut clover as well, tomatoes as well, maize is decreasing, potatoes are sort of fluctuating. And as you can see here the reason why sugarcane isn't planted. It's at the top right of the water use axis, so it sort of makes sense. Well, to conclude, the model has achieved a very big part of its goals, which are increasing the net revenue, and it has increased several of the parameters, yields, costs, prices, water consumptive use, as well as the area. The optimal crop mix has reflected the trade-off and the balance that I've talked about, and the net revenue has doubled from roughly $12 million in 2013, the total net revenue, to approximately $24 million in 2030. There are very slight variations between the scenarios, and we intend on enlarging the study period so as to see more differences between the scenarios, but at the moment we weren't able to project more after 2030 due to the data that we have. It's very short period and it's sort of impossible at the moment, but we intend on gathering the data and doing it. In the case of the wheat self-sufficiency constraint, we can see that the net revenue has decreased, and we have also observed that several of our results are justifiable. However, others need further investigation. And our future work includes seasonality, regions, and one of our main research interests is sea level rise. So we will look at it, we intend on looking at it from an inundation point of view, salinization, groundwater table rise, and we've already started exploring this part. We also intend on adding other crops, adding scenarios, and expanding the study period beyond 2030. And thank you.
Thank you very much, Nada. Excellent presentation, and congratulations on this good piece of work. And again, it adds to our evidence base, and it also adds to our toolkit. Because whenever an economist comes to you and says, this is the only single number that I projected and this is true, you should never believe him, because there are different approaches, there are always variations, there are always assumptions. And I think we get close to the truth once we evaluate all the assumptions and we look at things from different points of view using different types of models. And that's exactly what we are doing today. We moved from macro to the agricultural sector, and now we are moving even further down to more granularity in terms of subnational regions and to some extent household sector. However, I have started to hear at the macro level, I have not heard much about data issues. Now I start to hear about data issues, and of course the further down we dig, the more data issues, the more challenges we'll find and uncover. So I'm expecting to hear more about this issue from Hagar. So Hagar El-Didi is a research associate at IFPRI Egypt. She holds a BA in economics from the American University in Cairo and an MSc in interdisciplinary studies in sustainability from the Autonomous University of Barcelona. Hagar, please, the floor is yours. Thank you.
Okay, thank you, Clemens. Thank you, everyone. It's a pleasure to be here. So yeah, as Clemens said, I'll be taking it a step, kind of zooming it a little bit more, and talk to you a little bit about, again, the concept of climate-smart agriculture and a roadmap to our future research, which we hope to build on what we've been hearing so far. So first of all, what is climate-smart agriculture? We've already heard from previous presentation, and I'd like to just reiterate, is that it is a kind of a concept presented by the FAO in 2010, and it addresses both food security and climate change issues jointly. It's got 3 pillars, or 3 main objectives. First, to sustainably increase agricultural productivity and to support equitable incomes. And second, to adapt and build resilience of food systems and farming livelihoods. And third, to reduce greenhouse gas emissions where it is possible. And in that way, we enhance the achievement of the National Food Security Development Goals. But the thing to notice here is that it is not a one-size-fits-all approach. It's more context-specific. So what is regarded as climate-smart agriculture in one region may not be so in another region. And that's very important to highlight because it is based on the biophysical constraint, the socioeconomic realities of the region or the country. And so, for example, would we consider agriculture intensification climate-smart or a climate-smart strategy or not if we want to consider the case of Egypt? And the way I think about it is that Egypt is kind of already usually mentioned and given as an example really in this region of having already achieved a very high level of agriculture intensification with 3 cropping seasons, etc. And so maybe in that context, we could still make more gains, but maybe it's not the real focus here, because then we have to look at where it becomes unsustainable or where we reach that threshold of resource degradation. So this is one thing we have to keep thinking about. And also, so now these things we've already heard a little bit before, and what is really new about this concept? The first 2 pillars are non-controversial, and they're not new by themselves. However, there are kind of 2 additions. The first addition is that the 3rd pillar, which is reduction in emissions for climate-smart agriculture, is kind of seen as a co-benefit. So, for example, we can see that increasing sustainable productivity requires more efficient use of inputs. And therefore, that could lead to reduced emission intensity, and that means emissions per unit of output, but not necessarily the overall emissions of the farm. And the second thing is that we're looking at this as a systems framework, so not everything falls on the farmer, and it's not just the farm. We're rather including more of a broader range, the whole value chain in agriculture, and usually thought about as a landscape approach. And this 3rd pillar of emissions could be different from one country to another. For example, developing countries could be focused more on the first 2 pillars until they become more developed, and then they can look at the emissions, overall emissions, because agriculture is part of the climate change problem because it contributes to greenhouse gas emissions. But before we think about as a solution to climate change, we have to look at what are the constraints now from the agriculture perspective. So now that we know the definitions, I'd just like to recap where everything fits in this seminar. And so first we've seen the GCMs presented and downscaling models from Perry and Neda. And we have also crop models, showing the differences in yields and different effects of climate change on the macroeconomy, on sectors, and on crop yields. And we can see all of these to make analyses on very different levels. So the impacts of the economy-wide effects, we can use CGE models like Perry has presented. But that doesn't necessarily capture the whole picture, as she has mentioned. Like, if the agricultural sector is not significantly large, maybe it's not going to show in the macro effect won't really show. And so climate change effects and the effects on individual farmers may not show in this bigger picture. And then with crop optimization models, we go kind of a little bit further down, and then we zoom in more using household models, to see the impact on the subnational level, like on particular govern rates, where they are situated, and households or farmers, and different kinds of farmers as well. And this will help us, this kind of research will help us identify climate-smart agriculture strategies and practices that are suitable for each of these farmers, and overall, we can reach a kind of a national CSA strategy for the country. So I don't want to take too much time contextualizing this again, because we've heard, you know, the effects of climate change on Egypt, but we have to think about what kind of climate-smart agriculture techniques we use have to be making sense for an arid region like Egypt. So for example, if we think about rain harvesting as one of the solutions, it could have limited potential only for particular regions. And we know that this will all, you know, temperature rise is going to affect crop yields. We already have soil salinity issues. So these are the kind of things that are in Egypt's climate that we should be focusing on when we think of a solution. And the good thing is that we're not really starting from scratch, even though the concept is relatively new. There has been some research done in Egypt to show like what kind of climate-smart agriculture techniques would work here. So as my previous colleagues mentioned as well, like things like adaptation strategies, like crop varieties that are adaptive, maybe require less water, are drought tolerant, are heat tolerant, etc. Also, sustainable intensification has been mentioned, land leveling has been mentioned, and utilizing technologies to develop early warning systems, sending farmers you know, notifications and advice on what to do and when heat waves are expected to come, these sort of techniques. But what we want to ask here, because this is not very entirely new, is we need to take this kind of a level down and focus on rigorously analyzing the potential, you know, adaptive climate-smart agriculture strategies that are for different regions and for different farming groups. And I'll talk to you a little bit about how we want to divide this in a not very traditional manner. So I'd like to just share with you, this is upcoming research. We already just started the very first few steps, and we'll be continuing on, and we'd love to hear your insights about this. So we sort of have 3 research questions, and the first research questions is related to understanding the effects of climate change on agriculture yields, on farm incomes, and on rural poverty, and we focus on different groups, different cropping patterns, different regions. And so what we need to do first is take stock of what is happening now. What is the agriculture scene as it is before climate change is introduced? And what we're doing now is we're focusing on economic analysis of like technical efficiency and agricultural productivity, and we focus a lot on the efficiency and sustainability of use of water resources and land resources. And by identifying a farmer typology for Egypt, we can see like what works for whom and what doesn't, and be able to give less general recommendations of what is suitable, and what are the policy recommendations that can help in like increasing the uptake of these solutions. So now we come to the database part. So what we're trying to gather now, and we've already gathered much data, is to gather a holistic disaggregated database. So we've heard that you had some issues trying to downscale the data and get different regions, different govern rates. We've been partially successful in that, so that's good. And this is where like this kind of partnership can really be very beneficial. So we have, I want to talk to you a little bit about what the data sources we're using. We have data that we gather from national sources, like CAPMA, similarly, ARC, Ministry of Agriculture, and Ministry of Water, and we'd like to thank them very much for providing that. And we have, this data is divided into kind of three categories. One is for outputs on the subnational level, so things like the per crop, and we have actually per season. So we can do very nice collaboration here. So we have the area, production, yields of different crops in different parts of Egypt. And then we have on the other side the input story, the cost story. So we have inputs like, the cost of fertilizer, seeds, pesticides, labor, rent, machinery, all sorts of things per crop as well, and per govern rate. And what we plan to do is also merge this with data on household levels that we get from the Egypt Labor Market Panel Survey. And this is a very useful data set, has data on households' assets like land and machinery, livestock owned and sold, and also production and income. And then we can also differentiate between farmers that are only focused in agriculture versus farmers that are more diversified, etc. And so the second questions that we have is after we finish doing this, is that we look a little bit on, what are the climate smart technologies and strategies that are specific to these different regions based on what they are, producing right now, how they're producing it, etc. And see what are the impacts of climate change on them and how we can, give them recommendations for the specific technologies they should be using. And so the usual typology of households in Egypt in recent and previous research in this topic was mainly focused on dividing them with land size and just two categories, small farmers, large farmers, or subsistence versus commercial farms. And what we are introducing or hoping to do is divide them by more useful typologies that would allow us to give these, make more sense out of the story. So divide them, for example, by crop categories, wheat farmers or farmers who are focused on rice, by farm size also, small, large, or by area of land, but also by income diversity, as I mentioned. So are they only agricultural households, or do they have income from different areas? And recent IFPRI research, which you can see in the graph, shows that only around 20 to 30% of households rely on agriculture only and not on diversified sources of income. And many of these households are located in Upper Egyptian governorates, and maybe we should focus on these more in our analysis. And then also we plan to think about level of crop diversity as one of the typologies. So are these farmers only focused on one or two crops, or do they have a diverse enough crop mix? Because this will also affect how they react to climate change and how their incomes get affected and their livelihoods get affected. And if they have like a crop livestock mix, or do they only do one of these? Because also livestock as part of agriculture household has been under-researched a little bit. And so from our initial looks of the data, we can see that, farmers who are focused, like if we take this crop category or crop diversity category, we can see that maybe farmers who are focused on maize, fruits, vegetables, maybe are going to be more okay if water scarcity is our main constraint. It depends on what happens. So what we're trying to do is take the research that has been done in what are the projections, what are the climate change scenarios and their effects on water temperature, and just use that to see to reflect on the different households. What they can do. So these people, for example, may be more or less better off than farmers who are growing just rice or just sugarcane, who will be severely affected by something like that and may have to change their crop mix, as Nada mentioned. And then the third question that we have is related to putting things into practice. So as we mentioned, Egypt already has success stories in adopting rice varieties that are new and tolerant to heat, or wheat raised bed mechanisms to save water and increase yield. So we have a lot of research on this, and actually it is on the ground. There are a lot of farmers who do use these things and who have benefited from increased incomes and better productivity. But the question is, why we don't see any of these trends really picking up to a massive scale, even though we have so much research on this. And, in other words, what is hindering these small farmers from really doing this, from really practicing this? And so what we plan to do is do a cost-benefit analysis of the particular climate-smart agriculture techniques that we recommend for particular farmer groups. And this is an area that is a bit under-researched. And because we know too well that there are obvious barriers and they will change within one region to another. So, upfront investment costs, or farmers being risk averse, or lack of access to information, or the biophysical system just doesn't work for this recommendation. That's why we really have to look at the bigger picture and see all the possibilities of what will work and what will not work for this particular farming group. And so ask, what is the enabling policy environment that can increase the uptake of this particular technique that we recommend? So so this is basically what we are trying to do in the future. Right now we will continue finding the missing data gaps and see the data analysis that we have. And then after that, we will put this analysis to divide it by the typology that I just mentioned, and then using the climate change models that are already produced, identify the effects on the different crop yields, identify the suitable climate-smart agriculture techniques, do the cost-benefit analysis as well. So this is kind of the roadmap, and we are hoping that we can really work with many of you, because more or less you've already been involved in the research by either your institutions helping us with getting some data, or as inputs of the climate change scenarios. And I think what we have in common is that maybe if we work together, we really can find these data gap issues. We have some things you don't have, and vice versa, and we can talk about, the main issue that we are seeing now is that their data sets are from different sources, and not all of them align in a perfect manner. So we are hoping, yes, very soon to be able to fix this problem, and we'll be sharing with you our research, because this is very new, and we'll hopefully be having another talk soon to show us our results, show you our results. Thank you.
All right, thank you, Hagar. So when I see all these excellent presentations and upcoming research, I tend to strongly believe that in the next IPCC report, we'll have some solid evidence from this part of the world and from Egypt specifically. Now, I'm sure you have quite a lot of questions. Thank you for your patience. This has been a lot of stuff to digest. But now is the time where we would like to involve you with it could be questions, it could be comments, and there's a lot of ongoing research, as you have heard, that can still be shaped. So think of your contribution not only as a question, but as a contribution to further shape the research here. Okay, so who would like to ask the first question in the room? Please.
I would like to ask Professor Muhammad. Firstly, thank you very much for your interesting presentation. But it is just a question, if ARCA is changed its states from center for education, to be a part of the University of Alexandria to give a master degree, or it is just help the master degree candidate for information?
Okay, we may just collect a few questions. So think of a question. I think one of the things that we have seen is also the time horizon that we are looking at. No, it really matters if we're looking at 2030, 2050, or more. A lot of people say actually the really serious impacts will happen in 2100. So that's something we can discuss also, but we have the next question here.
Okay, actually I have many questions. Okay, so, and one comment. Let me start with my comment to Dr. Abdurrabbu first. Thank you for your new program. It's very needed in Egypt. I strongly recommend you to go on to make network, not only in Egypt, but also for our region. This is the first comment. Okay, second.
Sorry, one thing. Could you please introduce yourself also?
Okay.
Sorry, I forgot to mention this, please, very briefly.
I'm Walid Hassan, Associate Professor of the National Water Research Center in Egypt and Head of Farm Irrigation Management Department. Also, I'm Head of Climate Change Working Group in National Committee of Irrigation and Drainage in Egypt and a member of the International Commission of Irrigation and Drainage and Working Group of Climate. My question first was for Brihan. I have two questions for you. So you mentioned that you are working in hydrological model, mainly for hydropower generation. This one. So actually, hydropower generation working in the main system, main irrigation system, but this is for Egypt case is non-correct. So because there is other resources of water in Egypt. One of them is neglected, little bit few is rainfall, but it's very essential in other Nile River basin countries, which is rainfall. The other resources, which is essential for Egypt is nowadays, is reuse agriculture drainage water. It's very important. The second, you mentioned that water use efficiency at the farm level is very low in Egypt. I'm not with you in this. It's low, but not very low, because there is many constraints facing Egypt. For example, we have environmental problems such as salinity, and we have to add more water to combat salinity problem. And also we have social problems like land fragmentation and free cropping pattern, which affect of our system in Egypt. But anyhow, keep in your mind, water use efficiency at the farm level in Egypt is quite acceptable with those limitations. Okay, the second one for Nada.
Sorry, can I ask the gentleman to repeat the first question?
First question again.
Sure, yes, please.
Okay, first question. You mentioned that you are using a hydrological model for water. Okay, hydrological model, as I know, as a water specialist, it's working only, and you mentioned in the model itself, you work in hydropower generation. This work only in main irrigation system. But in main irrigation system, this will not working efficiently in Egypt case, because we have other resources in Egypt, as well as other Nile River basin countries. For example, in upstream countries, rainfall is very important for them, but they didn't count in their water resources. Okay, this is kind of gray water or green water, which is very essential for their water resources. But for our case, so hydropower or hydrological model, we have to consider many or other resources like rainfall or reuse of agricultural drainage water. Okay. Let me go for second presenter, Nada. You make some assumption that water use is the same from 2013 up to 2030. You mentioned this in your...
I think you mean the water used for irrigation, right?
For irrigation,
Okay.
yes. But actually, this is not correct. Why? Because simply our population increased yearly and water share per capita is decreased. For example, this year our water share in Egypt per capita is 550. A few years ago it was around 900 something. So year by year it's decreasing. This is very essential. Okay, number two, you depend on your water consumption, crop water consumption in crop water model. Our professor is here, he knows this very well. But crop water model, I mean, in near future, it will work efficiently because this depends only on meteorological data. And when we calculate crop water requirement depend on meteorological data, this is not correct. Because we have to depend mainly on actual crop water consumption. And there is new updated technologies which we are trying to use nowadays in Egypt. For example, we are trying to use ecovirance system for calculation, or for ecovirance for calculation of crop water requirement. And this soon we will modify aqua crop or crop water model to be more accurate for calculation of crop water requirements. And I mean, in general, we will try to modify Bendman-Montis equation. This you should keep in mind when you make some future calculation. So number two, also, you didn't consider social impacts, okay, in your model or in your calculations. Again, for social impacts, we have a big problem in Egypt, like land fragmentation and the free crop pattern in Egypt. This is very essential for distribution of our system. I'm sorry, I have many questions. Let me go for my friend Hagar.
Yeah, one each is fine.
Okay.
Or two each even is fine.
Okay. So, Hagar, you mentioned some criteria for calculation of or some assumptions for climate change. One of them is temperature rise. So this is not question, it's recommendation. For temperature rise, you know there is big difference between daytime and nighttime. Temperature rise in daytime is higher than temperature rise in nighttime. Okay, please consider this. And in case of Egypt, it's very essential. And I think in meteorological data, if you make any analysis, you will find this very simply. Okay, thank you very much.
Okay, very good. Okay, let's take one more, and then I'll give it back to the panel, and then we'll have another round. Please.
Okay. My name is Marwa Al-Wakil. I'm Director of Center for Special Studies and Programs at the Academic Research Sector of the Library of Alexandria. I'm not specialized in climate change. I'm a pharmacist, but I have a very simple question about these models that you're working with. How reliable are they in the data that you're getting? So it might be a very simple question, but since I'm not specialized, I would like to know about that. Thank you.
Okay, very good. Thank you very much. Now, let's start maybe from right to left. Nada, would you like to start?
I'd just like to correct or come to some points, and then I'll give the mic to Dr. Noha, because she's more of an expert in the fields you're talking about. But you've mentioned that the water share per capita decreases with the years. But the problem is that we are rather using the water available for irrigation, so as a total. But we would be delighted if there was any model that reflects the water available for irrigation or projects it to 2030. But we really exhausted all possible options to find one. So now I give the mic to Dr. No.
Well, precisely, actually, this is what I was going to say. I mean, you mentioned about the water available for irrigation. And actually, we have been trying to look into the literature and through all the connections, and as well as your esteemed institution, onto any references on the projection of the available water for irrigation, the projection for 2030. Unfortunately, we could not find any, and we did not find any feedback on that. So basically, we relied on the literature surveys that we had, all the literature that was referring to the quantity of water available is not going to be changing. I'm very happy that you say that it is changing and that you have references for that. So if you can provide us with the data and the references with the documentation, we would be really, really, really grateful. And same hold actually for the water user consumption for the crops. Indeed, we have used CropWatt. We have looked into other models, and actually we have conducted contact with many experts in the field. And again, CropWatt is not the best. However, we could not find something else which is better than CropWatt. So again, if you do have a model which can help us in the projection of the water consumption use for the 26 crops that we are considering, and even more, along with the input data which would be fed into such models that would give us the production, then it would be a great asset to us. So basically, what I wanted also to say is that the model that we have been using, it tries to make the balance in between the net revenue and the water consumption use. Although what we have measured is in terms of temperature, it was not very high. The water consumption use has increased, but not that much. However, we have seen changes, and this is, this sort of give us an indication that there are changes happening. Maybe they are not captured, in great details, but actually we were looking forward to this meeting because we need experts who are, in this hall to give us input. So that onto how to improve the input data, and but providing us with the data and the documentation for it. Thank you.
Yeah, and I think that's also a call for collaboration. Climate change science impacts is a very complex kind of undertaking, and no single institute, let alone one single person, can handle all the different dimensions. So it's a clear case of interdisciplinary work, starting from rainfall, biophysical, crop, economic, and so on. So I think this is really a good place also to talk about collaboration and sharing data going forward. All right, did you want anything else to say?
I just want to refer to the question of the reliability of the data. So after having explored the data, Hauger has already mentioned this, but there are usually differences between the different sources. So if you get data from one source, it's not 100% as the other source. So you cannot say that the data are 100% correct. You cannot say that the data reflect 100% of the reality either, but they are validated to a very big extent. So of course, it's not 100%, especially because it's the agricultural sector. But to some extent, they can be validated. So if this responds to your question.
Yes, and a good thing is we have representatives from CAPMAS here and from ARC, and a lot of these data come from your esteemed organizations. And again, I would like to join them to thank you for providing those data. Professor Mohammed, would you like to?
The point about the center is, as I said before, we started in 2011, which means we're talking about 6 years of work. The problem in Egypt is we have been so much consumed with the discussion and arguments about to what extent the Nile Delta will be inundated by sea level rise. And everybody's just saying it's 25%, some people are saying 50% and so on. And I have two problems with that. The first is nobody's just trying to understand what sort of processes, what sort of assumptions that different people use to get that results. Maybe we are talking about different scenarios. Maybe we're talking about different contexts. Maybe we're talking about different techniques. We are just arguing. My second issue of concern is that we are so consumed with this issue that we forgot most of the impacts of climate change, what's going to happen in Egypt and what we should act on that and what should be done. You cannot act without doing research. We have very limited research. The most relatively advanced sectors are the water sectors and agriculture. Most of the other sectors are almost we have no work in terms of climate change impacts, adaptation, and so on. I'll just give an example. We're talking about Nile Delta and what's going to happen in the Nile Delta. I have a question that I was trying to get some answer on, and nobody was concerned about this. Actually, most of the tourism in Egypt, foreign tourism in Egypt, is based on tourism in the Red Sea. Temperature is expected to increase. This will have adverse impacts on coral reefs. That will lead to bleaching of coral reefs. What sort of impact, the extent of the impact, how this will affect tourism, we don't know. We're still arguing about how much of the Nile Delta will be inundated. We have a problem with saltwater intrusion. Most of the delta is already having a problem with groundwater table levels. This will affect agriculture, will affect urban areas, will affect roads, will affect infrastructure, and so on. What's going to happen? Nobody knows. So in our center, what we tried is just to move things in different sectors. We're trying to push it, just a little push. We have never had any work done about biodiversity of the marine areas in the Mediterranean. We tried to do some pushing. We provided some technical support. We have a small research grant program, and we had some work done that shows that actually we have some problems. Biodiversity will be affected in the marine environments in the Mediterranean. We have a lot that need to be done. I'm not saying that we have to stop everything and just think about climate change. Just take climate change into consideration in whatever discipline. What are the health effects of climate change on Egypt? Big question mark. So what are we trying is to do, as I said, a little push, and also about the master program. Actually, we believe it's a further step. Again, it's a small step. What are we saying is, instead of just getting researchers to attend a couple of workshops and expect them to have good knowledge about climate change and how they should proceed, actually, we're trying to provide them with a program that provides good background in different disciplines, and also enable them to build on that to work in their own disciplines. We are part of the university, so nothing is changing, but instead of just having 4 days workshops only, we are just trying to have a more extensive program to support researchers in this line. Thank you.
Very good, thank you very much. Please respond to any question that you would like to respond. My personal interest would be also in your view on the data.
According to the modeling, you work with me in ICARDA, and we have started to choose a model. We give a rest of the models, and we check them, and the crop cysts and salt meds were valid all over the country. So I think that crop cysts on salt meds give a good idea, a good data in Egypt through the 5 years in ICARDA. Thank you.
Okay, can I kind of continue, since like the data issue has been brought up so many times, and ARC has like a lot of data. Yes. What is your general sense of the agricultural data in Egypt, and maybe your like policy of data sharing and things like that?
In the report of ICARDA. Every year we have annual data in the annual report, and has a data for all Egypt. You can find it.
All right. Okay, very good. Thank you. Great.
Thanks.
Hagar, would you like to comment? Or?
I mean, well, first of all, thank you for your suggestion on day versus time component of the temperature rise. And no, I just want to maybe reiterate that we, I mean, the data issues, of course, to an extent, this is in every country. You'll have some discrepancies in data. And the challenge here is to kind of try to make sense, and we are hoping that when we have more data, so we only have 1 year of data right now, and when we have more data over more years, it will be easier to see where 1 or 2 errors have been conducted and then easily change that. Yeah, so if we can hopefully like collaborate with more with the institutions providing the data, like the ARC and CAPMAS, we can easily validate more the data to have more accurate model, and that goes back to your question. You know, we need to really work hard on making sure that the data is correct. Thank you.
Yeah, because obviously once, if the data, like the baseline is wrong, then any projections will be wrong too. So it's really critical to get that right. Perry?
Yes, thank you very much for your questions. To the gentleman, yes, water use efficiency. I may have used the word very low, very before low. Maybe that may not have been a true indication. However, it is low because in the Sustainable Development Strategy that the government of Egypt had put out for 2030, they themselves acknowledge that it's low, and there are several studies that talk about that, simply because at the field level, it's inundation. I mean, it's not, the irrigation technique is not efficient, right? They just drown, they let the water run through the field, versus other irrigation techniques which are more efficient, like drip irrigation, more crop per drop, right, are more efficient. And part of their objective is actually to increase water use efficiency at the field level from 50% to 80%. So that's an objective that the government of Egypt has to have, or has, by 2030. And this is one of the assumptions that we also take into the model, is to increase water use efficiency at the field level. As for the hydroecological, so it's a hydroeconomic system. I'm not the expert. As I said, our framework actually built upon all the comparative advantages for each model. So the hydroeconomic model dealt with water and ultimately with crop yields. The energy model ultimately dealt with energy, and the CGE model, which is good for economic analysis, dealt with the economics, but with feedback from these other models. Now, it's the hydroeconomic system that is used. Again, I'm not the expert, but there is more detail outside in the discussion paper. Yes, that I have exactly. There are a lot of details on that, and as it was explained to me by our expert, is that the hydrologic model provides water information to the river basin and crop model through runoff processes. And through the crop model, especially the DSAT, they use temperature variation in order to allocate or to see the impact of temperature on the yields. Now, the hydropower generation, this part has not been used in the results that I actually submitted or discussed today, because this I'm going to be using as feedback into my energy component, which I have not actually yet done the analysis on. But definitely, and again, if there is a certain model, because hopefully this seminar will promote collaboration from all specialists. If there are certain models that you think the government of Egypt prefer to use in terms of hydroeconomic models, we are more than happy to actually collaborate and share with you on that, and you know, we can have EPTD, our division that actually deals with natural resources, get in touch with you. But yeah, and then once again, I do reiterate Professor Muhammad's comments is we need to start somewhere, right?
Yes.
We can't wait for the perfect data set, the perfect model, the perfect environment. We have to start somewhere and actually bring to the table this discussion that hopefully will help us move forward. And that maybe answers a little bit to the doctor's question where she said, how reliable are these results? There's no perfect model. There's no perfect model, there's no perfect data set, but there is a continuous effort to improve on what we have in order to hopefully optimize the end results that we can achieve. Thank you.
Would you like to add something on this? Yes, please.
Well, no. I'm just, I have one issue to raise that I would like to get some feedback from the panelists on. It's about downscaling. The work on climate change and downscaling in Egypt, all the work that has been done, let's say about sea level rise, has been using global trends, global projections, not downscaled, which means that it's very difficult to talk about reliability of projections and so on if the climate data are at the global level. So for us, concerning sea level rise, we are doing some work with the help of some experts on that to downscale sea level rise from the global levels to the Mediterranean level. And hopefully in a week or two, we'll have the outcome, which is far below what everybody has been working on in the sea level rise, the impacts, assessment of the impacts of sea level rise.
Okay, great.
So
we are
the
looking
issue
forward
here
to
is
that. 1
about-
week sounds pretty soon.
It's
We'll look out for
the
this.
issue of downscaling for the temperature and other climate parameters. What sort of work that has been done? Because I believe that when we're done with the downscaling, the data for the downscaling should be available. For us, that's what we're gonna do. Or else, everybody will restart the process of let's go and do downscaling again.
Okay,
So
I think we
what
got
sort
your
of work-
point. Yes, we got your
sort of
point. And I
work
treat
that has
this
been
as
done?
like the first question, and then I'll take another round of questions from the audience. Yes, please, the gentleman.
My question for Nada. Did your model consider urban encroachment and its associated impacts on the area of cultivated land on the future?
Urban encroachment. Encroachment? Okay, very good. So this is the last round of questions. So if you have any questions, please ask them now.
So I have a simple comment again to Dr. Abdrabbo. So I think International Center for Theoretical Physics, ICTP, in Trieste in Italy, they have two very famous models. One of them is global model, and the other one is regional model. And both of them under the Earth Physics System Department. I think you can refer to them. They did good job. Maybe in Egypt, it was included in RAGE model. You can refer to them also. Thank you.
Just on that point, I think you and ESQA with a lot of others are also working on downscaling for the MENA region kind of thing. That
But
maybe.
that's at the regional level, not
Right.
the national.
Okay, so any other final questions before I give it back to the panel? Do we have any questions from online? Fatma, any questions from online? Not at this point?
Not at this point.
Okay, very good. Okay, so please, maybe this time we start with Perry and then we come back over here. Any reflections on your final wisdom
Yeah, I don't know, after being jet lagged and not
sorry to
sleeping
put
well,
you-
maybe I have no wisdom at this point. But no,
Sorry.
but I think actually I have to say that I think from having worked on the region and especially on Egypt for some years now, you know, there is now the willingness to actually not only engage in research, the willingness, you know, maybe yes, the actual research results are not there yet, but there is the willingness to engage in research and use research to inform policy. And also there is an increasing willingness to really look at the data that we have and and converse and have a dialogue on the quality of the data. And not just that, but from having also worked with CAPMAS, there is also the willingness to share the data and to improve upon the data. To me, this is incredible, honestly. I mean, this is a huge step forward to actually acknowledge that some of the data we are using is not that great, and that's okay, that's fine. I think to acknowledge it is very positive. To acknowledge it and not do anything about it is, you know, is troublesome, but I don't think that's happening. I actually think that there is currently a willingness to really take a closer look at the data, see the quality, because there is a willingness to engage in research for policy information, and I think this is very positive.
Anybody else would like to say final words, react to any of the final questions? Professor Mohammed, Mahmoud, how about you? Nada, please?
So I have 4 small points.
Great.
So first of all, I'd like to reinforce Perry's latest comment, because we've experienced this firsthand upon working with CAPMAS. So there are positive endeavors that are taking place, and we can be sort of optimistic to some extent. And secondly, concerning the issue of downscaling, we have worked with this MarkSim weather file generator, which, as you know, there is statistical and dynamic downscaling, and it conducts dynamic downscaling. So we've worked with it, and our data are actually from the database, but and they are on a regional scale, and they are not even divided into region, but rather into governorates. It's not a local or a locally developed model. It's rather an international CGIAR DSAT collaboration model. And upon investigating the documentation of this model, to some extent it is reliable. I do not know further information about it or about sea level rise downscaling, but from a temperature point of view, I believe it is positive and it can be used. Now I have a small misconception that I'd like to clarify, which is regarding the data, because what we have been talking about as data needs is rather a finer granularity. In order to project for the future, as we've mentioned before, we need a large database or a large time series data. So this is actually the problem. I believe that lately, in the later years, starting from 2012, there are data on several variables. The problem is the older versions or the older variables and the data. So that is rather the problem that we are facing, and if anyone has any suggestions or knows where to look, we would be very delighted to know. Now, commenting on Dr. Mohammed's comment, concerning the issue of urban encroachment and the issue of social policies or social impacts, unfortunately, they have not been included in our model at this stage, and we haven't really thought it through at the moment. But if you have any idea concerning how to embed it in the model, because at the moment our model is rather more technical, agricultural, and rather away from the issue of urban encroachment or land fragmentation, among others. So if you have an idea, we'd be delighted to hear it as well. So thank you.
Very good. So thank you very much. I found this very stimulating and a very interesting and good contribution to the discussion. My takeaway is, in terms of the results, even if they are preliminary at this point, is that yes, we talk a lot about agriculture because agriculture, some role is in the economy, somewhat limited. We are expecting kind of limited macroeconomic impacts going forward. However, as Professor Mohammed has rightly mentioned, agriculture is just one sector. And there are many other sectors like tourism and others that may be affected. So I would assume if we incorporate the other sectors and their impact in the model, we would see more significant macroeconomic impact. Now, on the agriculture level, I think it really depends a lot on the time horizon. We have seen until 2030 some crops, you know, even the yield increases, some decreases, but probably the longer perspective that we take, taking into account what's happening upstream in the Nile Delta and the rainfall that will change in Ethiopia and elsewhere, probably we see like a progressive, more negative effect as we go forward. Of course, there is always like a positive kind of story. There is always technology, and there are a lot of scientists to work on, you know, climate and drought resistant and other crops. So there is, I think there is a lot of hope. We have to be aware that if we don't do anything, the impacts will be very severe. But the good news is if we start doing something now, I think we can mitigate a lot of these negative impacts. And then on the data front, I think we all agree that we have some data, but there is a lot of scope for sharing data. In my experience so far, it's not like there is no data. There is a lot of data that sits in different parts of Egypt on different people's computers. It's more like a matter of sharing the data. And I truly believe that it can be of everybody's benefit, giving and taking. So maybe that's a call. Let's not sit on our data, but let's share the data and hopefully help to shape Egypt's future in a good way through doing that. Now, the second kind of observation that I have is that talking about numbers and evidence-based research can really help, no? Because of course we make ourselves vulnerable. We say, okay, we think the effect will be between 2 and 3%. And then a lot of people will say, but no, we don't think so because your assumption is wrong and all of that. But this process in itself is very informative. This is a very good process in getting the numbers as close to reality as possible. Because we can argue always, well, the water use efficiency is it low or very low? What does that mean? I mean, what does that mean? Maybe I think with very low something else than somebody else. So putting numbers at specific problems, discuss them thoroughly, discuss assumption, I think is a very, very important part of the finding the truth, and that will help policymakers to make better decisions like going forward. Now, finally, I would like to thank the Library of Alexandria for this excellent seminar. There has been quite a lot of collaboration already in the past, but we'll also meet after this and to see how we can, you know, further work together. And I would also like to thank USAID because they are funding IFPRI's Climate Smart Agriculture work, and they're also funding this IFPRI Egypt Seminar series, which brings me to my final point in case you haven't heard. So we are doing IFPRI Egypt Seminar series more or less on a monthly basis on different topics and with different partners. And I would like to invite you to join our next IFPRI Egypt Seminar, which will be at the Cairo University with the Faculty of Economics and Political Science. And it will be launching the IFPRI's Global Food Policy Report 2017. And among the distinguished speakers will be Her Excellency Dr. Heller, the Minister of Planning, and IFPRI's Director General Schengen Fan. And you can always join those seminars also online. There is always a live stream in case you don't want to go to congested Cairo and spend a lot of time in traffic. Okay, so thank you very much also to you for coming, and I hope to see you soon again. Bye-bye.